All right. I'm going to start yelling at the mic, get our intro in, and then we'll get going. Hey, welcome back to another episode of the Ruby Rogues podcast. This week on our panel, we have Valentino Stoll.
Hey now.
I'm Charles Max Wood from Top End Devs. We already have people coming in on the live stream, which is awesome. I think they're all coming in on Twitter. We have a special guest this week. That is Stephen Margheim. Stephen, welcome to the show. Do you want to introduce yourself real quick?
Yes, thank you for having me. As you said, my name is Stephen. I am living here in Berlin, Germany, though I am originally American. Just got married earlier this month.
I saw that on Instagram. Berlin. Congratulations.
Yeah, thank you. And excited to be here and talk about SQLite and Rails.
Very cool. So, where do we start? I'm just going to give a little bit of context because, I've used SQLite, but everything I do on Postgres. I think most Rails developers go that way. But I think SQLite is also the default if you start a new Rails project, or at least it used to be. Anymore, I just tell it, no, I want Postgres. So yeah, if you're talking about SQLite like it's a serious database on Twitter.
I know, weird, right?
I know. I couldn't think of a better way to put it, but the way you talk about it and the way we talked about it on the Ruby Dev Summit, you made it sound like you could honestly use this in other places. And I've heard other people being interviewed. I think somebody from Planet Scale or one of the internet hosted databases was talking about how SQLite is the real deal now too, not just MySQL or Postgres. So yeah, is it the real deal, and why? Change our minds.
Well, it is the real deal, but like with any database, and this is, I think, the key point, there are trade-offs. So at like a very high level, just my sort of sense of things, right? Like Postgres is great because it comes with a lot of functionality out of the box, and it has a really rich community of developers and set of extensions. So right, you want to be doing stuff with vector databases, you've got PG Vector, you can plug that into your Postgres database. But compare that with MySQL and the VTES sort of layer that can be put on top of that, and the scaling that has been done in the last 2 decades on MySQL. There aren't the same sort of solutions that are as battle tested at the same level of scale for Postgres, right? So something like Planet Scale, which is sitting on top of VTES, is a relatively unique offering for MySQL. And then SQLite has, I think, a unique sort of value proposition because it offers you like the full range of SQL. Like there's really nothing that you need to do with SQL, the language, that SQLite doesn't offer. You can, if you want to, run it in a client-server architecture. The libsql project, which is a fork of the SQLite code base by the Terso guys, and the platform that they are building on top of that is like bringing the client-server architecture on top of SQLite for edge computing. But you have the option, which is unique with SQLite, right, to run it on your application server machine right next to your Rails process and just simply remove network latency as a consideration. And I think that the major shift that has been happening in web development lately has been a growing recognition that SQLite is production grade software for web applications, with the caveat that you do have to configure it to be ready to use for web applications. And where I think there has been this odd disconnect is that there's been the sense that, like, oh yeah, Postgres, MySQL, these are obviously web application databases. Just get them up and you're ready to go. But of course, you have to configure those as well. Like, there isn't really a database that is completely blind plug and play. And as people have started lowering that barrier to entry and just started to demonstrate, hey, there is a lot of power here. There's a lot of flexibility here. This is a model for building and deploying applications that offers some unique value adds, whether it's to developer experience or to performance or to simplicity of deployment. And I think it really is just a question of education around what it takes to get a robust, resilient, production grade deployment of an application backed by SQLite out into the world. And that education has been growing in the last couple of years. So yes, it is the real deal.
So I want you said production grade like 12 times. I wasn't counting. I'm just throwing the number out there. But what do you mean by production grade?
Yeah, so I think that there have been three major barriers to using SQLite out of the box in a web application. And I think it has led to the sense that SQLite isn't production grade. So the first barrier is concurrency. So everyone who has read even a little bit about using SQLite for a web application will very quickly come across people claiming, hey, you absolutely could never use this for a web application, because in order to have a web server that can deal with even just a reasonable amount of requests coming in, you're going to take advantage of the stateless nature of HTTP and deal with multiple web requests concurrently with your application process. But SQLite running on that same machine is going to linearize your interactions with the database. And by default, if you don't touch anything, you're using the original model that they have for ensuring transactionality, you're going to have linear operations, whether they're reads or writes. So if you want to do anything, you do them one at a time. So the fact that you have concurrent web requests is negated. Everything bottlenecks at your database, and people say, of course, that's never going to scale. Now, there are two key points to make on this barrier. The first one is people really too quickly forget to do like the basic math on if you remove latency and you give yourself some headroom. So you go from talking to a Postgres database over a web connection, which can take some number of milliseconds, to talking directly in process to SQLite, which can take some number of microseconds. You have 10, 100, up to 1,000 more opportunities to do things, right? When you move from milliseconds to microseconds. So even as you linearize things, you're dealing with different orders of magnitude of latency, and that gives you possibilities. And then the second one is that you can configure SQLite to have concurrent reads, but as of now, there is no way to get concurrent writes. So out of the box, SQLite is linear operations. Web applications tend to deal with concurrent operations, and people think, well, that's a hard no. But it isn't. That's barrier one. Barrier two, and I'll just stop at barrier two, it's the main one, or these are the main two, would be around backups, right? People are like, hey, this is ridiculous. If you want to have something that's like making money on the internet or is in some way trying to be valuable, you need to make sure that it's resilient. Something happens, we know how the world is. The servers can get unplugged, or um, storms come in, who knows what, right? If you have everything running on one machine, and including your persistent data, and that machine goes down and your persistent data is now gone, well, it's easy to spin up a new machine in a new application process, not so easy to recover lost data. So the fact that SQLite is on that same machine, that you don't have network latency, is a vulnerability for persisting your data and keeping your system resilient to system failures. And in the last couple of years, there have been a number of tools that have been built to back up SQLite databases to some other place, and to make it easy to take those backups and spin up a new instance of that database somewhere else. Probably the most well-known one now, the one that I have used the most, is a project called Lightstream, which just streams writes to your SQLite database to an S3 bucket, or really any S3 compatible bucket service, and has a very simple CLI. And you can just pull it back down onto any machine. So when I say production grade, I tend to mean these kinds of ideas where people think about, like, sure, I can do this like quick script on my laptop, and it's nice to have some quasi-persistent storage. But if I'm trying to build a business, if I'm trying to build a SaaS, if I'm trying to build an application that I want to have some meaningful presence on the internet, I'm going to need to have the ability to handle concurrent web requests. I'm going to need to have the ability to spin up new web servers with my application and keep my data persistent across them. And there wasn't always a clear story for how simple or easy or possible that was to do with SQLite, and that story is being written much more clearly now.
Okay.
Yeah, I think first of all, you have a great series, blog series that we should link to on successful usage of SQLite in Rails and configuration and performance metrics and all kinds of great stuff that I think people should read and dive into. And I guess, like, my biggest, I've been on the same boat of incorrectly thinking for the longest time that SQLite is not performant, and don't use it in production, but sure, in development or whatever, testing, or even just like small like hobby apps, sure, it could be fine. But once you get above a certain level or scale or whatever it may be, then it don't use it. And I'm sure I'm not alone thinking this, right?
Yeah, not at all.
And so, right. And so you do shed quite a lot of light on, okay, there's a lot of buts in a lot of those, ways of thinking. And I definitely agree with you there. And I'm kind of curious, like, to get some further insight there on, what are the limitations, right? Like, well, what point do you hit SQLite and then it no longer work for your app, right? Because I think that's where a lot of people are still hesitant to dive into it, because they still don't know what that barrier is. And then it's one of those things where, okay, you don't know it till you know it, and then it's too late, and then you're trying to scramble to find another solution, right? So, like, what are those things, right? Like, what should you be looking out for to know if SQLite is the right option for you?
Yeah, it's a good question. It's the question I get most often, and there are a few different angles to take on an answer. One of them is, where are you comfortable in investing your time? Right. So if you're someone who you're trying to start up a side project, you're hoping to get some money with it, or just sort of do something of interest and value, and you have a decade of experience with Postgres, and really feel comfortable, like, with the path to evolving a system over time with Postgres, just stick with that. these days, it's there's really not actually a lot of limitations with SQLite. So here's like the first big one that used to be more of a limitation, right? So there's a major difference between SQLite and Postgres, MySQL, Oracle, like pick any of the others. Most database engines follow the client server architecture. So it's like you minimally have two different processes, and most of the time you have two different machines. You've got a machine running your application, you've got a machine running your database. And you most often, right, have multiple clients, have multiple machines running your application and one machine running your database. And you talk to your database through web requests.
Mm-hmm.
And there's been decades and decades of exploration of like different ways to scale that kind of architecture, to make that kind of architecture resilient. And when you go from an embedded database, there's one machine, there's one process, everything is just happening right there, to something like GitHub scale, Shopify scale, right? Like there's no vertical scaling will never be able to handle that. You're going to have to horizontally scale. So then how do you horizontally scale when your database is living on each machine? That was a problem. That has been a problem for a long time. And so I have said, if you are starting a project and the way that it succeeds is it gets to that scale, right? Like if you go and get venture money, you probably should have chosen MySQL from day one, right? Like you're shooting for planet scale, not TM, from day one. But that's actually not even a technical limitation anymore. So whether it is the predecessor to the Lightstream project, LightFS, from Ben Johnson at Fly.io, which is a tool to have a replicated logical database spread across multiple machines, SQLite database, obviously, or whether you're using a platform like Terso, which, as I said, like brings that client server architecture, but also allows you to have read replicas on each of your machines, and it'll manage consistency for you. Like there are now, and there are others. There are multiple tools now to allow you to horizontally scale a SQLite database. So is that particular scaling path as battle tested as like the tests on MySQL? No, it's not been around for 2 decades. You don't have a company like YouTube that's running it. So again, it goes back to like your risk profile. If you think on day one, I really want to be at that scale, you probably should just use MySQL and VTest, right? Because why take the risk if you know that's where you're going? But for someone who is like unsure of what the future looks like, I really do think that there are so many wins that you get on day one and week one and year one with the developer experience and the performance characteristics and the power and simplicity of like leaning into vertical scaling for as far as that'll take you, that you should really give SQLite a long look. And you can fall back on the security, be like, if you really do get very successful such that like vertical scaling can't work for you anymore, you don't have to change databases necessarily. But the other thing that's true is like, if you do get to that scale, you're probably making money and probably good money. And at that point, you probably could change databases if you want to. And going from a SQLite schema, which is, it's going to be a looser schema, typically to Postgres or MySQL, I think is generally easier than the reverse direction. So I talked around your answer. The short answer is I really can't think of like really hard limits, to be perfectly honest with you. But I do think that there are different risk profiles and there are different reasons why you might or might not choose to use it. But like as of today, okay. I say that, of course, I should say out loud. There is the one key limitation, right? Which is if you have like massive write throughput, if you're building an analytics platform to compete with Google Analytics, and you're just going to get like the core of your business is you need to deal with massive amounts of writes. Don't choose SQLite today. That would be a hard limitation. They are working on concurrent writes, so that limitation might not be true in 1 year. But for today, I would not build a analytics platform on top of SQLite. How about that?
Yeah, that makes sense. I mean, I'm thinking more. I mean, would you also not build an APM with SQLite?
Yeah. Again, it does sort of like come back to your expected growth profile. I have built an APM with SQLite. It's a very like it's an internal small one, right? But it was like I'm not expecting if the 37 Signals crew have talked about load testing their SQLite backed Campfire application, and on the biggest machines that they have, with their cloud exit, they're running their own machines in a data center, and like their beefiest machines, they're getting 50,000 concurrent requests. Are there APMs that could handle that? Like, yes, right. If you're like, I want to build a business and I am either the next App Signal or I have failed, yeah, I probably would not choose SQLite on day one. Again, my sort of hot take on this is, and all of the recent internet drama aside, I personally would probably choose either SQLite or Planet Scale on day one. Like those are the two options I would choose. It's like I'm either going for big scale, and I know that, like that's the characteristics of the app I'm building, or I'm just doing regular scale. And SQLite handles regular scale, quote unquote, right? Like good luck getting, if you can build an application and you have 50,000 concurrent requests, like good on you. You have definitely succeeded. So short answer is maybe, honestly, maybe.
It's just funny to me because SQLite comes out of the box with Rails, and for the longest time, you question it, like nobody's using SQLite. And the more you use Rails, and the more like one-off apps that you start to make, right? Like even just like trying something out, like it's great. It does most of what you need, right? Like, and I feel like most people won't even hit the limitations of it or see any side effects of that. Until much, much later, to your point, where there is an actual, limitation, and you have the financial, ability to navigate that, right? And I feel like most people won't even get there, to be honest. And I mean, in all honesty, thanks to the Shopify folks for all of their efforts with it, as far as like, Lightstream as an example, but all of the other integrations to just make it super straightforward to get set up and operational. Like, I don't know. I feel like why bother? Why bother having like? I'm definitely coming around to that off the cloud idea for it specifically. Of why have all these extra services that just aren't needed, and it's just to help you scale, maybe, right?
Yeah, I mean, this has been one of my like major realizations and principles that drive a lot of my personal interest in the topic is a recognition that, like for me myself, I really am trying to be conscientious about fighting off unnecessary complexity. Like it's just swarming around us, and especially like for where we are at in the evolution of the internet and the economy of the internet, right? Like everything is a SaaS now. Everything is a product now. It's like, hey, you need authentication? Here's the SaaS you buy. You need emails? Here's the SaaS you buy. And it is, it just like grates on me to see how like common the mind virus, I'll be sassy, is that the correct way to build a web application, a service, a business is to sign up for 15 different SaaS platforms, stitch your things together, have no real ownership or understanding of like what your Franken app is doing. And then like, I mean, and we've been seeing more and more of it, right? Like, and then you actually get some success, or more commonly, the actual noise of the internet and the people who just like doing naughty things and having their little bot farms run. And you just like, boom, all of a sudden you're like, whoops, like I have a bill for $10,000 on this one service for this month. And yeah, as you said, I mean, it's like, it's actual like statistics, like most applications are not going to actually need, like there's real value there. I'm not saying that most of these businesses shouldn't exist. They should exist, but most people shouldn't pay for them, right? Like servers are cheap. Servers are easy. Like I'm no DevOps genius. I'm certainly not an ops genius. I barely can use Docker, but I have spun up many servers in my day, and it's not rocket science. I have maintained them. That's also not rocket science. It's not incredibly stressful. It can be when you make like mistakes, and that's why this concept of production grade is important, and to have a sense of like, what does it mean? To give one specific example, I had an application that we use at work for business that provides profit running on SQLite. And I had been thinking for a while, I really need to go in and install Lightstream and set that up, but I didn't get around to it. And then one day I was cleaning up and renaming my applications to make them more consistent. And I did not recognize that in the little web platform, that when I rename an application, what it's going to do on the server is it's going to do RMRF and then redeploy. Oh. And it wiped my SQLite database, and I spent like a full day trying to recover it from memory, and it did not work. And I had to go back to the business, and that was a shitty day. And I made sure to put in backups after that, right? So this is why I do bring up production rates. Like, yeah, you can foot gun yourself, but you can fail to set up backups for Postgres or MySQL or anything. But like, none of these things are difficult. And it just saddens me to think that so many developers, and especially newcomers, like come into web development and think like, you have to understand Docker and Kubernetes and serverless. You have to pay for 15 SaaS platforms. It's like, man, it's going to take a PhD in web development and at least $500 a month to even like start to do something. It's like, that just isn't true. Like, more people can get started with less prep and less upfront money. And I really want to make it as widely known as possible. Like there is this alternative path. You can just go get a DigitalOcean droplet, put a Rails server in a SQLite database. Like, you have one machine, and you can grow that. You can just in your little DigitalOcean dashboard, like you could just bump it up over time, and you can do that for a long time. Like, go and look at the biggest machine on there. It's really big, and it can handle a lot of requests, and SQLite can handle a lot of requests. And these things like can be cheap, and they can be simple, and that opens up so much opportunity for like experimentation and more people coming in and trying things out. And that's what drives the passion behind it, right? It's like, doesn't have to be this other way.
Yeah,
that
I feel you
that
on the
reminds me.
simplicity thing.
Yeah, it just reminds me of CGI, right? Like back in the day, you had a directory CGI, and you uploaded a programmable file, and it ran. And it was that easy. Yeah, everybody had FTP client or whatever. You just uploaded the file, and then you were ready to go. And like people ran like legit businesses off of it,
Oh yeah.
where guitar tab sites, or like all of the original search engines. It was just like a handful of programmatical files in a directory somewhere, and it just ran. And I feel like maybe we're like a little bit beyond that, right? But it should still be that easy. It's like the underlying technologies haven't really changed that much. Like you still have servers and clients and a browser, and it's those three things. uh yeah,
Yeah,
why make it more busy?
I was just gonna add, with all the different SaaS products you can add, right? So top end devs for a long time ran the authentication through one of the authentication services out there that you pay for. And yeah, it was more work to set up and manage that than it was for me. Eventually, I just switched it back over to Devise, right? Because I set it up once, and then yeah, occasionally I have to help somebody reset their password or something stupid, right? Hey, oh yeah, I jacked that up. Let me fix you, right? And yeah, I feel this on the rest of the infrastructure too, right? I mean, one of the things I really like about Kamal is that it kind of does that, right? So it pulls down the Postgres Docker image, it pulls down the Redis Docker image, it pulls down, a Ruby Docker image, and then runs my Docker file against it. And then it says, hey, that's over there, and that's over there, and that's it, right? And load balancer, it does the load balancer too. And that's what I love about this. So yeah, having something simple where it's just like, oh yeah, it's just going to run alongside the app server, right? Run alongside Puma or whatever. Yeah, this is beautiful, right? I don't have to fuss about it.
Yeah, exactly. And then on top of it, you get like these really nice benefits of like it's I would recommend for developers to just like spin up an app and throw it up somewhere, right? Use Kamal, use Hatchbox, like use whatever. Like do it quick and do
Yeah.
it easy and just like play around and get a feel for what it feels like on like two fronts. And this is where it like really sold me and I like became passionate about it. So the one is it's just really nice to have a simple enough system that you can keep it in your head. And so the fewer moving parts, the simpler the system. And like I have these applications that I have built at Works, sort of like these R&D applications that I am effectively the sole developer and maintainer of them. And, I'm an engineering manager. I'm in a lot of calls. I have like these 30-minute windows sometimes between calls. And I have to debug production issues that come up. And I can actually do that. I can go from like, I haven't heard anything. I get a Slack message. I read the problem. From that moment to I have checked that the fix is live and fixes the problem in production. I have consistently been able to do that inside of a 30-minute window for over a year. And that is like a magical feeling. I every single time I do it, I'm like, wow, this feels amazing compared to most of my work experience. And that is like driven by, I have a Rails app and SQLite installed. That is it. I have nothing else. I don't have Redis. I have nothing. I have like 4 different SQLite databases, right? I've got my queue database and my cache database and my models database, or production database is what it's called. But I have this one piece of software, and that piece of software, I don't have to do anything weird or fancy. It just runs inside of my application process. There's nothing to like spin up. I don't need to have a proc file necessarily. Right? is there. And that like developer experience is so nice. And then like on top of it, it's just like a file. And so if I need to, which I've done many times, right? Like a production issue comes in and I can tell, some data has gotten out of sync here, but I don't know exactly how or where or what. I need to dig into the data, and I can literally like do a safe backup. I can use the fact that I have these Lightstream backups. I can just tell Lightstream on my laptop, hey, replicate the database to my laptop, please, as of right now. What is the current state of the database? So I get a mirror of the production database on my laptop. I spin up the app on localhost. I've got all the production data, and I can mess around and figure out like, where did the data go wrong? Where's the bug in the background job that messed this up? And I know it's completely safe. I don't have to remember to do the -- sandbox in my Rails console or any of that. And it's like, one CLI command to get it down there. And there's like so many of these little things, whether it's one of the first articles I wrote was on doing database branching locally with Git. And it's like the simplest thing in the world to set up with Rails. And it just removes an entire class of problem that has annoyed me for a decade of web development. When you're working across these different branches and your schema gets borked. And there's just like, they stack all of these things. And then at the very end of it, you're like, oh man, every single database operation I have done went from N number of milliseconds to N number of microseconds. Like I just got 100x performance improvement. Like Action Pack is my bottleneck for all of the Rails apps that run the stack, so that is awesome.
Real quick, just dive in deeper to the branch specific databases you're talking about, because I thought this was fascinating reading through this. Like how does that setup work, and what are you saving there?
Yeah, it's a really nice feature. Let me start off by explaining like the problem. So here's the scenario that many of your listeners are likely to have experienced. You're working in a feature branch. So you get checkout -B feature A. You get to work. It's a long running feature branch, kind of complicated. As a part of the feature work, you have to make changes to your schema. So you generate, let's say, 2 different migration files. You added a new table, and you have renamed a couple of columns on an existing table. While you are in the middle of working on this feature branch, a major production issue is reported and a bug fix needs to be made. Someone has created a hotfix branch and they ask you to review it. You're like, okay, I did the code review, but I want to make sure before we push this live that like the fix is actually doing what we wanted to do. So you git checkout hotfix 1 and run your application, and things aren't working. Maybe like your Rails app won't even boot. Maybe as you boot into the app, things aren't there. And you're like, what in the world is going on? What is broken here? Something is very clearly broken. And what has happened is that the schema changes that you made to your single only local, development database in feature branch A are still there when you checked out hotfix 1, but hotfix 1 doesn't expect those changes to be there. You rename some tables or some columns on some tables, and the code in hotfix A expects the database to be in the schema as it existed in main, but your schema locally is different. And so the database and the app have a mismatch and things blow up. This is so annoying. So you have to like get your database state back into a correct place and then be able to, once you're done reviewing that hotfix or however, you change branches and you get back into the feature work, you want to bring those changes back. So that's like the problem. And it's an annoying problem. And there are various gems out there to try to help you with that. Here is the simplest, most resilient possible way to solve that problem. If you could, in some magical way, have every single Git branch have a completely separate database, well then, definitionally, you would never have this problem. That would be nice. Now, when you're running Postgres, that might be tricky, it might be possible, or it might just be computationally expensive or space expensive. Who knows? I've not really honestly tried it. But with SQLite, it is both cheap and easy. And all that it requires is you take advantage of the fact that the database YAML file that Rails uses is processed by ERB. So you can just throw some ERB in there. And in that ERB, you can run shell commands. So you can just plop in there, hey, what is my current Git branch name, please? And you can make that the name of your database. So now you have dynamic database names. Then the only other thing you need, SQLite itself will automatically touch a non-existent database. So if you say SQLite, please open database A, that file doesn't exist, SQLite will just create an empty file. So all you need is to ensure that when you start your Rails app, if your database hasn't been loaded, right, run your migrations, load the schema, however you do it, that it is, right? So you just want to say, take whatever the current encoded version of my schema is in my repository and run that. So what I typically do, and I think what's in the article is like it will run your migrations. And you can do an after prepare block in your development.erb configuration file. So with those two changes, what you have done is you have set up a system where whenever you change Git branches and in any form you boot your Rails app, so that can be starting the Rails server, that can be starting a Rails console, that can be using the Rails runner, it will create, if it doesn't exist, a new database file. It will run all of your migrations and get the state set up. If a database file does exist, but there are some new migrations, it'll just run those new migrations and get the state to where it needs to be. And you can then enhance that if you wanted to. That's like where I stop in the article. I need to write some more about it, but it's very easy to enhance that. And like you can do seeding, you can have generic seeds that are always run. So you can have a baseline set of data that's populated into all of your branches. You can set up some branch specific seeding such that you, and you can make that more generic, like around scenarios. There's all kinds of fun things, but in general, you have the ability to have completely isolated, like actually separate databases for each of your Git branches. And so it simply becomes impossible to run into the super, super annoying when it happens, because it's just like, you're completely blocking me in the moment where I don't want to have to deal with any of this. These schema conflicts as you move across Git branches.
Yeah, that's interesting. I mean, how do you not mind data getting blown away between branches at that point, or have you solved that problem and like, stream some updates?
Yeah, so for local development, I have ended up with a mix of a couple of things. And I have a couple of later blog posts about this, but I should honestly finish up writing some of the other stuff I've done. But in general, I tend to start off with just like a generic seeds file. It's like, let me have some usable data. And yeah, that 75% of the time, that is sufficient. For some applications, I have ended up in a place where it's like, well, I have kind of built up whether it's like pulling down a production database or pulling down a staging database, like I want to keep this across branches. And I have just written some Ruby scripts, basically. I have a blog post about this. So it's like, DB clone, and I just say, okay, I want to take this database and I want to clone it into a new file with this name. And then I am just wiring up the name that I point to in my database YAML to that. And there's some automations you can layer on top to connect that to Git if you want. For the most part, what I have found is like when I want to control the actual data, the schema and the data. I was like, I want this file that I sort of move away from the automatic Git branching stuff, and I just manually go in and say, comment out my default database line and database YAML and just point it at a particular file. So if you were to look at like my laptop for most of the apps I work in, and you look in my storage directory, on average, you will probably see at least 12 different SQLite 3 files in there. Because I just create a bunch of these different scenarios. I've pulled down production on this date. I've pulled down staging on that date. I've created this Git branch and that Git branch, and they all live there. And sometimes I manually point my app to one of them, or branch off and just do manual branching as if it were Git and be like, well, I want to sort of play with the schema and the data in this direction and give that a name and wire the app up to that. And it's all, it's like quite simple, but it is quite nice to be able to like have that flexibility. Your schema, your data, you have the full range of like logical branching that you could do with Git and text files with your database.
Yeah, it's super cool.
Yeah.
I mean, looking more at the configurations you got for like having multiple databases, all SQLite. Like, do you find that there's like a limitation point of like too many databases of the same SQLite server, like serving for, or where it's just like becomes too unmanageable to like reason about all of the different things, right? Because I saw you have like solid errors, which is kind of interesting, where you're like storing all of your errors off to its own database. Cache, I imagine too, right? Like you start like stacking up all these different databases. Is there a limit to the madness, or is it like still pretty reasonable, for everything that you'd need?
So if there is a limit, I haven't hit it. The most databases that I have in production is like 6, I think. And like operationally, that it's nowhere close to it. I'm not even sure if there is a limit. But conceptually, no, it hasn't been that bad. What I have found is like, for the nature of the system, I'm going to have this bucket no matter what. I'm going to have to do some kind of IO for an object of this type no matter what. And for me, it is a conceptual win to keep the actual operational infrastructure there like the same. I have been able to become a master of Rails and SQLite, and that's it. And I can do everything I need. So I don't know all of the Redis commands. I don't know all of the Redis data structures. I have a passing awareness of them. And I wouldn't know how to optimize a Redis instance for caching. I don't know how to optimize a Redis instance for background jobs. I don't know, would Redis be a great choice or a terrible choice for the backend for something like solid errors, storing exceptions that happen in your application somewhere. So being able to leverage a flexible, powerful tool across these different problem domains and give myself the challenge, but also give myself the time to become a master, to be like, I know how to optimize SQL queries for caching. I know I've spent time and I've thought about that, and it's just SQL, and I know that language and I know it well. And I know how to optimize like how to structure tables and what kind of queries to run, and make sure I know how to optimize SQL and SQLite for a background job queue. And I know how to do that for errors. And each one of those, I am able to leverage expertise that I have gained in the past ones. Like there's a lot of overlap. So if you want to have a good schema for your active record models, a lot of the wisdom and principles that you're going to learn in that problem area are going to roll over when you're like, well, what would it look like to back a queue, a job queue with SQL? Okay, let me think about how to, schema that out. What kinds of queries? How do I want to deal with this stuff? And what's really nice in the Rails ecosystem, as 37 Signals has gotten into building new applications, has gotten into SQLite, and has been exploring the benefits of reducing the number of moving parts and publishing more of these solid star gems, solid queue, solid cache, solid cable, I imagine is being worked on, is that I don't even have to be the only expert. There is now a community of experts. And I read through for example, the solid queue source code, and Rosa did a way better job at it than I did, So it's like, I just get to take advantage of the fact that she is a really top-notch developer who spent a lot of time thinking very deeply about how to structure a queuing system backed by some persistent SQL database. And I just get to run bundle add, So I haven't gotten anywhere close to a limit, and I have actually found, like, every single time I do it, I'm like, I should have more databases. Like, I'm right now working on another gem, which is like the conceptual sibling to solid errors. I think I've named it solid metrics, right? Which is just, let me keep track of the metrics. I want to know them. I don't have super high needs. I don't have a lot of customizability. I just need to know the basics. Rails instruments itself already, it's the same thing with errors. It's all instrumented. I just want to put them somewhere and put a very basic web UI on top of it.
Mm-hmm.
And, I've got like 3 more ideas on top of it. So probably, come back to me in 2 years, I'll probably have like 12 different databases in some application somewhere in production. And might not be ready to stop there either.
Very cool. So I guess my question is, because you said I know how to optimize SQLite for a queue. I know how to optimize it for something like solid error. I know how to optimize it for, whatever else. How do I figure that out? I mean, do I just Stack Overflow the thing, or how do I know how to tweak SQLite for my use case?
Well, I'll start by just distinguishing one small point, which is that, for those particular domains, that's just SQL, not SQLite. Like what kinds of tables with what kinds of columns and what kinds of indices.
So
and
you're
what
talking
kinds
just
of
structure
access
and then
patterns.
query
Yeah,
structure.
So somebody, Mike had to think about which Redis data structures and Redis commands should I use to have a resilient and performant job backend. And other people have thought about, if I wanted to like have those same behaviors, but I wanted to back it with a relational database, like how should I structure my tables? What kinds of indices should I have? What kinds of queries should I write? How do I do that resiliently and performantly? That's a SQL problem.
Okay.
But when it comes to SQLite, I would say there are sort of 2 parts to an answer to your question. So one part is, one of my goals is to make the amount that you or anyone else would have to learn about SQLite to make it work incredibly well for a Rails application specifically and for a web application more generally, as close to 0 as possible.
Right.
So,
that's what I want too, as the user.
Yeah, I think, and it's what I would have wanted were I not the person who got, sort of infected with the bug of really getting into it. But one of the great levers that is available in using a web application framework is that these kinds of things can be pushed into the framework itself. So, we made a number of changes to the default configuration for SQLite as a part of Rails 7.1. And that there were 6 changes. I have a whole blog post about it. Like those 6 changes alone make a massive difference. And if you take a default Rails 7.0 application and put it on the internet, you're going to experience pain. And if you put a Rails 7.1 SQLite application on the internet, you will experience notably less pain. But still some pain, and we are solving the major pain points at the Rails level itself. So whether it's improving concurrency or improving the performance of talking to SQLite, sort of like the Ruby and C bridge. I really want to have as much of that live in the framework as possible. But of course, as for anything, like your app is going to have some special use cases, some things where you're going to have to move beyond the framework. And so like, how do you learn to take advantage of SQLite? And I would say that there are like roughly 3 things I would recommend. So the first one is the SQLite docs are extensive, and I personally find them quite approachable. I mean, like it's not just like here's all of the C code, and it's not just like here's the interfaces. I mean, it's been around for 30 plus years, and you can see they've talked about just about everything that's in there. And it has a nice little search bar in the top. And they also have a form, and you can search that there. And there's just a lot of valuable content there. And you can really find a lot of answers to many questions. Just search the forums, search the docs. So reach for that first. Secondly, for like situations where, I sort of have this unique problem, or I kind of want to do this somewhat unique feature. How can I do that with SQLite? There is a fairly robust, I don't know numbers. I haven't dug deep into Postgres, but there are a lot of SQLite extensions, and they add all kinds of different functionality. So whether it's, the hot new stuff of storing vectors in your database so that you can run some form of AI feature inside of your application. Like, there's a SQLite extension for that. There is the equivalent of PG vector for SQLite. You can add it in, you can store vectors, you can query them and retrieve them, and many, many others. So start there, see like, hey, is there an extension to do this? And then the third one would be, if those things fail, there really has been a growing number of people interested in working with this, and the online community, in my experience, has been very welcoming and very positive. And you can just throw something up on Twitter, on Stack Overflow, and I think you're very likely to get some useful and good responses.
Super cool. Well, we're kind of at the end of our time. Was there anything else that you wanted to make sure that you covered, Valentino?
There was something I'm trying to think of it, but
he had you at machine learning. I know.
Yeah, I know. I got sidetracked in my head. I have a lot of questions there, but yeah, I guess like, have you hit any limitations as far as like, I think of like, as an example, JSON columns in Postgres, or doing, database views, or things like that, where, maybe SQLite doesn't have the feature. Have you found many limitations in that regard, that where you had previously, reached for a certain tool that you no longer have available because of the database limitation?
So the short answer is no. But let me just add, like, I really hope people will just believe me, I guess, when I say that I'm not like shilling, right? SQLite is not paying me any money. I am not making any money by talking about it. I'm not trying to get you to, buy my SQLite SaaS or anything. So this is, I'm not just trying to like be a hype man. There's no value or utility in it for me.
Right.
It is interesting that like I was in the exact same boat. Like, I don't know what it is. There's just like something, a general myth on the internet that's like SQLite is anemic. It just doesn't have a lot of functionality. It's small, it's weak. It's like, nope. JSON columns, got them. JSON operators, got them. Generated columns, got them. Views, got them. Stored generated columns, got them. Honestly, there are really only two features I've been like, it'd be really cool if SQLite added them. So one is GIN indexes from Postgres. Like, that's just a really useful, generic index. It's nice to have. SQLite doesn't have it. So you can have SQLite columns, but you can't index them as easily. And if you wanted to do something like that, you do have a workaround. Like, you can make a stored generated column to sort of like extract out the parts that you want to index as a stored generated column, and then index that stored generated column and query against that. But doesn't have GIN. GIN would be nice. And then, of course, right, like, it would be cool if you could do concurrent writes. That would be great. You can't, but that would be nice. Aside from that, I personally have not come across any feature that I have needed to or wanted to build that SQLite didn't provide. And I was, in fact, surprised, actually, as I dug into it more, like, oh, okay. SQLite actually does support like basically the full, it supports the full SQL standard. And a lot of the stuff that isn't in the standard that, Postgres or MySQL are like, this would be a nice feature. SQLite is like, sure, that sounds like a nice feature. I'll add it. So I'm not just a blind hype man, and I don't think SQLite is the solution to all things, but really, genuinely, I think there are a lot of limitations. Like, we need to start fighting back against this myth that it is an anemic tool. It's the most widely used database in the world. It's the best tested database in the world. It is older than the other two major databases, MySQL and Postgres. Like, it is resilient, it is powerful, it is well tested, it is flexible, it is easy to learn. Like, there really aren't reasons to not use it, unless you're building the next, Fathom Analytics, and you really do need 1 million writes per second. Then, yeah, there's a reason not to use it.
All right. Well, I'm going to push us to picks.
Just one last note. There's a famous learning experiment where if you wanted to like learn a new language, as an example, there's a build your own SQLite database kind of tutorial that lots of people follow, because it does like, everybody wants like a REPL, right? Like, everybody wants to be able to store data, read data from files, right? And like SQLite does all of these things that are very just common patterns for languages. You have to learn to do the core tenets of whatever it is to make it be a database, like from a file system, which is kind of interesting. So speaking of picks, I might as well pick that. It's like how to build a SQLite database. But I've definitely started one in Rust, which is just for fun. And it's amazing how simple, like, as you mentioned, SQLite, it really is under the hood as far as storing things. And it's just fun. It made me think about it.
Cool. All right. Well, I'm going to push us to picks. Valentino, you got some picks?
Yeah, I've been loving Olama, which I know has been mentioned on this show before and by others, but it is a way to run local inference on your machine against many different open source large language models. It's kind of fantastic. It runs as a server, so you can serve many different models, optimized automatically with whatever GPU you're running, and you can configure it to offload some of that to the CPU. And it's pretty fast, and just it has saved so much time just like investigating and evaluating other models that are out there. And you can even build your own models and serve those locally, which is kind of wild. So I highly recommend checking it out if you haven't.
Awesome. I'm going to jump in with my board game pick first. So I went to SaltCon, which is a local board game convention, and I really had a good time. Just hung out with one of my buddies the whole time, and we ran into some other people we knew there. So anyway, it was awesome. So shout out to SaltCon if you're in or around Utah. They're doing another one in June, and I'm hoping to get a ticket to that one. I haven't bought one yet, but we're kind of doing that thing. Also, before I do that, I should probably mention that I am looking for work. So if you're hiring contract or full time, I would love to hear it. Chuck at topenddevs.com. All right, so the game I'm going to pick is a game I played there. It's called Apiary, and so Board Game Geek, I'm just going to warn you, this one's on the more complicated end. It was definitely fun. There were some unique things, but Board Game Geek has a weight of 2.96 on it. That's out of 5. So, there are 4s and 5s, and usually those ones will run for hours. Apiary did not. I think it took us an hour to play it with 4 players, but it's pretty involved. So, if you don't like the games where you have a ton of stuff to keep track of, then this isn't the one for you. But if you want one that has some mechanics and, you have to kind of figure out which strategy you're going to jump on, it's a terrific game. It was a lot of fun. It's kind of a blend between like worker placement and, I don't know, there were some pretty unique mechanics. So, every time you placed your worker, if there wasn't room for your worker, then you would bump somebody else off the board, and that bee would go back to the hive, but it would get promoted. And then once you got promoted, if a 4 got promoted, it'd hibernate and then go back to 1, right, instead of level 4. And so anyway, but the number on the bee and the number of the other bees on a particular spot also determined what you could do there. And so anyway, and the number 4s also have unique abilities at each space. So anyway, lots of stuff, just really, really interesting game. It was almost too much. There were almost too many things going on to make it just super laid back fun. But anyway, I did really enjoy the game. And it's on my list as one that I may eventually go buy. So I'm going to pick it. Now, if you didn't pick up on the theme, apiary is like an aviary is for birds. Apiary is for bees. And it's space bees. So you're adding onto your spaceship and stuff like that. So anyway. So that's my board game pick. And I'm actually just exhausted because I've been working on a bunch of stuff for Super Tuesday because I'm involved in state politics stuff here. So I'm just going to end my picks there and just remind you, if you want to hire me, to let me know. Stephen, what are your picks?
Yeah, so I am friends with Joel Draper, who built and maintains the Flex Gem, if anybody's heard of that. And if you haven't, let me give you a quick intro there. Flex is a Vue component gem for Ruby, not the Vue component gem, but a gem for writing views in Ruby. And specifically, it does everything in Ruby, right? So it maps elements to method names and attributes to keyword arguments and children to blocks. It's a really great gem. And specifically lately, the core team has been working on a really awesome feature that I want to make sure as many people as possible know about, because I actually think it can, I hate to even say these words, but I think it could possibly revolutionize how we do our Rails applications. And so what is the feature? The feature is selective rendering on the server side. So conceptually, it is very similar to how turbo frames work, right? So you have a turbo frame on your page. It has ID turbo frame 1, and you click a link inside of that turbo frame. The way that would be managed by Rails presently is like that link gets sent up to your application. The controller processes it, finds the appropriate view, renders that view, sends that view back down to the client. On the client side, there is JavaScript that says, oh, this is a response from a turbo frame request that we made. We made that request from turbo frame 1. Let's parse this view and find where turbo frame 1 sits inside of it. We'll pull it out, throw all the rest of it away, and replace the contents of turbo frame 1 with the new contents of turbo frame 1. So on the server, you're rendering everything. So you have some waste, but you have the benefit that you get to use your existing Rails routes. You get to keep all of your existing controller logic, rendering logic, database access logic. So you treat it as if it's just a regular page visit. But you have excess content that is sent in the response. And then on the client side, you have to take all of that content. You have to parse it and find the subsection to pull it out and replace the frame. The feature that Flex is adding now allows you to do that exact same thing, but all on the server side, right? So you send a request up from turbo frame 1, and you say, hey, I want turbo frame 1. It's just a regular link to a regular normal route. Controller receives it, goes to render it. It's rendering a flex view and not an action pack view. And that flex view is past the content that context. Say, hey, we want turbo frame 1. And so now all of your flex views, it'll start rendering, and it's just going to no-op all of those methods, so your HTML, your body tag, your H1 tag, all of that. Okay, those are methods. We're just going to no-op them until it finds the method that has ID turbo frame 1. It's like, oh, okay, now it's time to actually render. And so then Flex will render all of that content, package it up, and send back just that div or section, frame, whatever, So you get 2, or I guess 3 big benefits. So the one is you get to keep the same simplicity of your Rails application getting to be structured as if all of the interactions you're doing are standard stateless HTTP interactions, full page refreshes. You don't have to set up a whole sort of like separate components namespace where you render specific things. But you get the second benefit of sending the minimally small payloads over the wire, only the content that you need, with the third benefit being that you only have to render the content that you need. So your rendering times actually speed up as well. So this is available now in like the alpha release of Flex. It will be generally available when they release version 1.10. And we're doing a lot of thinking and a lot of work now to really make the integration with Hotwire and Turbo as seamless as possible. But I think that this kind of general shift in thinking and leveraging these kinds of tools is going to be really useful and valuable for Rails applications. So that is my pick. Flex selective rendering.
Awesome. Very cool. All right. One last question. If people want to find you on the internet, where are you?
Yeah, so I am at Fractaled Mind on Twitter and GitHub. My blog is fractaledmind.github.io. And if you want to meet up in person, or you just want to get more confident and comfortable with building Rails applications with SQLite, I am going to be at RailsConf in Detroit in May, and I am hosting or leading a workshop there on the second day on building Rails applications with SQLite. And we're going to cover like everything that I know in as much as that is possible. So the goal is that coming out of that, everyone will feel comfortable and confident with using this stack and using these tools. So a lot of exercises and content there. It'll be a fun 2-hour workshop. And otherwise, happy to meet up, have a soda with anyone in Detroit as well if you're going to be there for RailsConf.
Awesome. All right. Well, let's go ahead and wrap up. Thanks for coming, Stephen. This was awesome.
Thank you.
All right. Till next time, folks. Max out. All right. Hang on for a second while we end the stream.